What's up guys, welcome back to the channel. In this video I will be building this air-to-water intercooler for Eddie from Autopilot Exotics. Eddie builds custom exhausts and twin turbo kits for exotic cars. His most popular product is his twin turbo kit for a Lamborghini Gallardo, and that is what this intercooler will be going to when we're finished with it. In this video I'm going to be giving you guys some tips on how to make parts like this that will last, perform, and look great doing it. Eddie is an artist, and although his intercoolers are proven on cars with over 1,000 horsepower, he's continuously looking to improve his product designs. When I'm done building these intercoolers, Eddie and I are going to work together to come up with a new design that focuses on aesthetics, improves airflow, and reduces fabrication time for the Autopilot Exotics twin turbo kits. With that being said, we'll jump right into the video. Stick around to see the fab of these intercoolers, as well as some CAD work in designing the new ones. All of these parts have been handled by their producers, shipped to Eddie, handled by Eddie, and then shipped to me. So there's a high risk of contamination on them. I think of it as people would think of food. The more food is handled and processed, the less quality it becomes. It's the same with metal. The more processes that it goes through, like these end caps being machining, there's coolant involved, and who knows if the tooling that they were using in the machine was clean. So the more processing that a part goes through, the higher risk of it being dirty. So we're going to use this Scotch-Brite wheel and clean off the surface of our parts, and we will of course wipe down with acetone, as you should do at a bare minimum. A lot of people say that using Scotch-Brite can be more harmful than helpful, but I have used it in a lot of situations. I've used it on bend tests, and it has never given me an issue with porosity or contamination, as long as you use acetone afterwards. This intercooler core has a metal finished surface, and that is always a source of contamination because it is done with sandpaper, and the sandpaper leaves behind grit that is, by the process, definitionally embedded into the material. Also, the sheared or laser cut edges on these plates always introduce contamination. This is a little before and after on the cores. You can see unclean versus cleaned. And here's a little bit more of that metal finished surface. I'm very intentional with the Scotch-Brite. Go nice and slow so you don't get scratches in it. And it looks nice when you're done, when it's a nice straight grind line. I'm not sure if these plates are laser cut or sheared, but either way, that is a common source of contamination, so we want to get that surface layer off so it is clean when we weld our end tanks on. You can see here, again, I've got you a nice little before and after so that you can see the difference between unclean and the cleaned surface. You can see it's nice and shiny and consistent and smooth. As I said, always going to use acetone. Everything that we hit with that Scotch-Brite, or even if we're using a stainless wire brush that's dedicated to aluminum, we always want to get that grit that's left over from an abrasive process, get that out of our weld area. And same thing with our filler rod. And when I say I wipe this stuff off till it comes off clean, I mean it. The first wipe, you'll have a nice black line. I'll wipe this stuff 5-6 times on each piece of filler wire until it truly comes off with no dirt. The first and most important step in building these air-to-water intercoolers is ensuring that we have the correct orientation. The AN fittings that you see here on the end caps have to be in the right spot on the car to accept coolant lines. If you guys are doing any work for anyone building them parts, whether you have a blueprint, you're going off of pictures, or just word of mouth, ask questions and get the orientation of the part right. That is the first thing that will get you brownie points with whoever you're making parts for. In my how to weld aluminum video, I said that the water that you see here was coming out of the pores in the aluminum. I was corrected on that. For those of you who corrected me, you were right. It is only on the surface of the part, but I still think it could have an effect on weld quality, so I recommend a light preheat. I'm starting out here with 200 amps on the machine, metering it with the foot pedal. I'm at 60 hertz at first. That wasn't running very well, so I turn it up here to 100 hertz, and that is much smoother. I am running about 65% AC balance for a little extra cleaning. Although I don't think I needed it, I probably would have been fine at 70, although no harm is done. I'm using my filler rod hand here to hold down the end tank as the tacks from the other side pulled it up a little bit. It's actually a better idea than what I did to tack on one side and then go diagonally across to the other corner and tack there next, so you don't get as much pull when you get to your second side. It's always a good idea to do a dry run before you run a weld to make sure that you're comfortable and you're not going to outrun your range of motion halfway through the weld. I really like the wide, flat welds that I have seen others get on intercooler cores, and so that's what I'm going for. It is a really fun thing to do. You get a bit more amperage and add a bit more filler and let that puddle get really wide. The only difficult thing about that is when you add a lot of filler to aluminum, the puddle tends to jump up quite a bit, and if your arc length is not long enough, you can nick the tungsten with the puddle. Not really a huge deal unless you get it really bad and you get it all over the tungsten. In this case, it was not bad enough and I was able to continue with the weld. In this video, I've got the auto dark lens on the camera so you guys can see a little bit better. And I struggle with the same issues and also with feeding the rod with my filler hand. I don't do that too often, but over the course of this job, I get a lot more comfortable with it. I'm still dipping my tungsten into the puddle a little bit here. The solution to that, again, is just to pull your tungsten away and have a little bit longer arc length so you don't hit it when you add filler. In this clip, I correct my mistakes and slow down a little bit to get a little more comfortable with feeding the filler with my filler hand, and this one goes pretty well. I don't dip it. I'm keeping my arc length long enough that it's not popping up. Those improvements really pay off. This weld comes out pretty nice. Still not perfect, but a lot better than what I did on the past two welds. So I'd like to see them a little bit flatter, especially these ones are going to get ground down. So keeping them nice and flat is a good idea to save time grinding later on. What you see me doing here is wrapping the previous weld around this corner so as to cover our previous stop. The fisheyes in aluminum are prone to cracking, so it's a really good idea, especially with something that's going to be pressurized, to make sure you cover all of those fisheyes. Of course, the final one on your last weld will not be covered, but to have as few of them as possible greatly reduces your risk of cracks down the line. In this clip, you can see I'm getting a bit more comfortable with feeding the filler and running these joints, so I'm speeding up a little bit. That's something I would always recommend to you guys if you're struggling. Slow down a little, get the rhythm, get the feeling, get it looking right, and then you can speed up. Slowing down, you want to decrease your amperage, and in most cases that will help you get the hang of it. Now that our end caps are done, we can build our end tanks. Since there are 4 identical end tanks, I could build all 4 at once to save some time, but on parts I've never done before, I like to get through one and see what I learn and apply that to the next one. It sucks when you realize you should have done something differently, but it's too late to change it on the next part because you already welded it together. These plates are laser cut, so I'm cleaning off the edges using a grinder as the laser cut edges are full of contaminants. You could also use a clean file dedicated to aluminum if you don't have a grinder. Another before and after here for you guys. You can see on this laser cut edge, if you know what you're looking at, there's quite a bit of aluminum oxidation on here, and that is going to have a very bad effect on the quality and cleanliness of your weld. And when you compare that to the cleaned version, you can see it's a little bit more shiny and consistent, and it doesn't have that black aluminum oxide that the laser cut edge does. Now I'm switching over to a Scotch-Brite wheel again, and we're going to clean off the flat sides of these parts and also deburr them. Burrs can increase your chances of cracks and can also prevent good fusion on the backside of a weld. Like I said, same reason on the cores. We are hitting this with the Scotch-Brite because these have been handled and shipped multiple times, and we want to get a fresh, clean surface on there for welding. Now to weld up the end tanks, I'm still running 200 amps, no pulse, 65 AC balance, 140 on the AC frequency for a little bit more accuracy with the arc. Of course, I am not using all 200 amps, maybe 125 to 140 on this 1/8 inch plate, and I'm squaring up my plates and giving them a light tack corner to corner. We will be welding the inside of these as well as the outside. Eddie has given me some tips on these over his years of fabrication experience. He has seen multiple intercoolers on other builds crack, and so he's very preemptive with that and make sure to prevent that by welding his both inside and outside. So I skipped ahead and got the inside of this guy welded up. This is a pretty tricky thing to do. It's a pretty tight spot, but it's just for a seal and a little bit extra reinforcement. So we got that done. We're going to go ahead and weld our little inlet and outlet flanges on. We got a 3-inch outlet, 2.5-inch inlet, and both of them, of course, are bead rolled because Eddie's going to be using some silicone couplers. So we'll get those tacked on from the outside, welded on the inside, welded on the outside, and then we're going to weld our end tanks onto our core. I also want to mention, after tacking and welding this, I did grind my tacks flat where they spilled over the sides so that that wouldn't affect my final weld. So that's a good tip. Grind them flat so they're not hanging over there and leave a bump or a inconsistency in your final weld. Right here, I'm looking at which side will be facing up in the car, so I know where I want the start and stop to be on the weld so that it's not visible on the final product. Before I tack this other end tank on, I want to clean off this side of the core since it has been sliding around on the steel table and could cause contamination, so I hit it with the wire brush and some acetone. This is how I thank this torch after doing all that welding. It's actually only rated for 150. 200 on AC is, that's a lot. Good job, torch. You get the fan now. For the final part of this video, we are in Fusion 360 designing up the new end tanks for Eddys intercoolers. The ones you just watched me build are very time consuming, and the square corners on the inside are not the best for flow. So we're using Fusion 360's sheet metal design feature to make some bent ones. This will save Eddy a ton of time in welding and also improve flow and aesthetics a little bit. I gotta tell you guys, I am not an expert on Fusion 360. This isn't going to be a how-to. This is just some little clips of my process sped up. If you guys are interested in more Fusion 360 content, drop it down in the comments. If you guys want to learn from the little bit that I know, you can join my SKOOL community. There's a link down in the description. It's completely free. Talk about welding, and we can start talking about CAD too if you guys want to learn more about that. These end tanks actually took me quite a few hours to get the first version down. We're going to have to order a set, test them, and make sure everything's right. But I think they did come out pretty good looking. I've got to make some mirror images for the other side, and then I will definitely be posting some pictures when we are building the first prototype in person. Let me know down in the comments if you guys like the design here. I think it'll be super helpful for Eddy. Cut down on his fab time, improve flow, look a little bit nicer with fewer welds. I hope you guys enjoyed this video. If you did, don't forget to like, comment, and subscribe. And make sure to check out this next video because YouTube thinks you'll like it.